started. So, first of all, when we do our lesson on Monday, it's going to start with Pythagorean theorem. One of the things about that lesson is not that you don't know the Pythagorean theorem, is going to be how to apply it to much harder problems than just here's a simple right triangle, find a missing side. So it's going to dig deeper on Monday, and when we do that, because to solve for a missing side in the Pythagorean theorem, you often take the square root, you end up with a lot of radicals in that section, and you will have some on the homework where you not only have to simplify a radical, and we've done some really simple basic ones in here so far, but you will also have to add them, subtract them, multiply them, and divide them. And then also in section 5.8, 5.8 is going to be something new you've never seen before, which is special right triangles. We'll talk about a couple special right triangles and some relationships, and then you're going to end up with a lot of radicals. And so there are some rules about radicals you're going to have to know. Not only for that lesson on Monday, but then moving into Algebra 2, we will use everything we're going to talk about today in Algebra 2. Normally, when you take Algebra 2, you take it the next school year, and so Mrs. Siegert in Pre-AP usually does another radical review. I probably won't do that in here since we're doing it today and I'm keeping you all year long. I don't really feel like we should need to do that, okay? So once we learn it today, practice it tonight on our homework. Next week, you're going to have a special quest, if you want to call it. It's not really a test, but it's not really a quiz because it's worth more points than a small quiz. So we'll call it a quest. Yes, we're going on an adventure. So we will have a quest on the day before we take the Chapter 5 test. So, and it will take probably about an hour for you, if not longer, to take it. It'll be 20 questions, and it will there will not be a review for it. What you're doing today, the homework you're going to go home with, will get back to you graded with all the correct answers written on it, and then this homework assignment will be what you want to use to study with. You can always go online and Google adding radicals, subtracting radicals, dividing, multiplying, and get more practice, but these questions and answers will be your study guide, okay? So before we take that quiz, you'll want to turn this in, get it back graded, and then use it to study with. So next week we'll have that quiz, and then we'll also have our Chapter 5 test next week. So the way it's going to be is, just kidding, oh, I'm looking for one day. Yeah, it's over here. Sorry, I'm trying to plan way ahead. So next week, your Chapter 5 test will be on Thursday, and your radical test will be on Wednesday. Okay? 2 tests in a row. The reason I'm doing it that way is so that we can review for the Chapter 5 test on Tuesday and give you 2 nights to study for it. So the radical test will be on Wednesday. There'll be no homework on that night. You'll study for your Chapter 5 test. Vocab test will be on Tuesday, the day we review for the Chapter 5 test. Okay? So that's the plan for next week. It'll be a lot of stuff, but hopefully there'll be good grades as long as you practice hard today. So, first of all, I want to say simplify completely means you need to look for a couple of things. So we're going to come back to what completely means, but we'll start with simple things that you have already talked about. So we should know to simplify something like the square root of 12. Very simple. What do we do to simplify the square root of 12? Okay, so it factors into what? Okay, we could do 2 and 6. Remember that the fastest way to factor these are going to be to look for your biggest perfect square that goes into it. So 4 is the biggest perfect square times 3, and then you can take the square root of each one, and that gives us 2 square roots of 3. It is not wrong to do 2 and 6 and then take 6 down to 2 and 3 and look for a pair. It's just that as you're trying to get quicker and problems get harder, we're going to look for shorter ways to work them if possible. Okay? So 2 square roots of 3 would be our basic simplifying. Okay, they're going to get harder than that. So here's some notes for you on just simplifying. If you have something like the square root of 2a over 2b, first thing I would tell you to do is look and see, since it's all under the square root, if they can reduce. So can we simplify 2a over 2b? So that becomes what? Good. So simplify it to the square root of a over the square root of b. Always try to make your numbers smaller when you're working these before you make them bigger, because you won't get a calculator. So it's super important that you're making them as small as you can before you have to work with bigger numbers. A and B won't simplify any further, correct? So then another tip or trick that you could use is to take the square root of each one separately. So you could do the square root of A and see if it will simplify, and then the square root of B and see if it will simplify. And I'm not talking about A and B as variables. I'm saying some number that doesn't simplify with some number. Okay, you're not going to have variables on your problems today. They're all going to be numbers. But I'm just telling you that these numbers, A and B, do not simplify. Okay, so if they don't simplify, then you can separate them and take the square root of each one separately and try to reduce it. If B will not completely simplify, it's not a perfect square, it won't turn out to be something like 2 or 3, it stays the square root of 2 or the square root of 3. You are not allowed to have a square root in the denominator. You are not allowed to have a square root in the denominator. One of the things you're going to look for when I said simplify completely is you're going to check every answer before you circle it and ask yourself, do I still have a square root in the denominator? If you still have a square root in the denominator, you are not done. Okay? So I don't know if you guys learned this back in Algebra 1, but it's called rationalizing the denominator. Multiply it by what? Exactly. So you should have been taught in Algebra 1 that you weren't allowed to leave a square root in the denominator, and it's called rationalizing the denominator. And all that means is you're going to multiply the top and the bottom by the denominator. So that means to multiply, and I should use correct mathematical words, the numerator and denominator by the denominator. Okay, so you're going to multiply the numerator and the denominator by the denominator. So for example, if we rationalize what we have here, what is our denominator right now? The square root of b. So what we would do is we would write the square root of a over the square root of b times the square root of b over the square root of b. You're going to multiply both the numerator and the denominator by your denominator. Okay? And if you do it correctly, every single time you should have the denominator times itself, which turns out to be, hold on, let's do the numerator. When we multiply the numerator, we just multiply those things underneath the square roots together. So that's going to be a times b. And that might simplify once you multiply them. You can see if it'll reduce at all. And then on the bottom, we'll have the square root of, what's b times b? Careful not to be b squared. But what's going to happen when you take the square root of something squared? Okay, it's just itself, it cancels out. So what's going to happen every single time is that square and square root will cancel, and you will be left with just a number on the bottom. So you're not allowed to leave your answer with the square root in the denominator, and you're going to rationalize it to get rid of it if you still have it. Okay, and by rationalize, it just means multiply by the denominator over itself, and then it should simplify away. And that would be your answer if it doesn't simplify. Okay? So I'm going to give you an example with actual numbers to make this a little easier. Okay, so here is an example. 4 square roots of 20 over 16 square roots of 40. Okay, again, the very first thing you're going to try to do is simplify. Always reduce, make your numbers as small as they can go before you try to do anything else. So what is something you notice that we could simplify here? 4 over 16, what goes into both of them? 4. So this turns into 1 over 4, right? Okay, what else could we simplify? Very good. 20 and 40, since they're both under the radical, you can reduce them. They either both have to be outside the radical or underneath the radical. Okay? So since they're both under the radical, 20 goes into itself once, 20 goes into 40 2 times. Now be careful, there's still a square root there, right? So this turns out to be 1 times the square root of 1 over 4 times the square root of 2. But we can simplify that numerator. What is the square root of 1? 1. And 1 times 1 is 1. So this is really just 1 over 4 square roots of 2. Agreed? So notice how we made everything smaller. We did not try to start multiplying by 16 square roots of 40. Do not do that. You will not have time to do that, and your numbers will be so big without a calculator. So there's no sense in doing that. Make it smaller first. Okay, now what do we need to do since nothing else will simplify? Okay, rationalize the denominator. We're going to multiply the top and bottom. What are we going to multiply the top and bottom by? Just the square root of 2 is all you need. If you multiply by 4 square roots of 2, you're just going to end up reducing those 4's back out. The square root of 2 is the only part you need. So when we rationalize the denominator, you really only have to multiply by the square root part. Okay? So square root of 2 over square root of 2. Multiply straight across. What do we get on the top? And we don't need to keep that 1 in front. We can just write square root 2 because there's always an implied 1 in front, just like the variable x always has a 1 in front. What are we going to end up with on the bottom? Good. Good, because this is going to become 4 square roots of 4, and then the square root of 4 is 2, and 2 times 4 is 8. So the answer would be square root of 2 over 8. I want you to not do that because I know that in the future math classes, they're not going to want you to put that 1 there, okay? In future math classes, they're not going to want you to put leave a 1 in front. So she said, would I count off if we did put a 1 in front of the square root of 2? And I don't want you to do that. It's like writing 1x every time you write x. You don't need that 1 there. So you want to try to get out of that habit of just putting x equals, okay? Can these reduce, the 2 and the 8? No, one of them is under a square root, one of them is not. You can only reduce if they're both outside or both underneath. And so this would be your answer. So you're going to check, do you have a square root still in the denominator? No. Can your square root simplify? No, square root of 2 cannot simplify. Can anything else reduce? No. So when you're checking simplify completely, you're going to ask yourself, do you have a square root in the denominator? Can your square root simplify? And can anything else simplify? Before you circle your answer, these are the 3 questions you want to ask yourself every single time. Do you have a square root in the denominator? Can your square root simplify? Or can anything else simplify? Are there any numbers outside square roots that can simplify, underneath square roots that can simplify? And that is simplifying. So I'm going to pass out the worksheet. This is only the first thing we're talking about today. The front side of the worksheet is just simplifying. And I'm going to let you guys vote on which one off of this worksheet you would like to do together. And we'll work one off the worksheets. But then I need you to put the worksheet away because you're not going to start working on it right now. We still have 2 more topics to talk about. Okay, so you guys pick. Take a look at them. Decide which one off of worksheet number 1 you want to do together. So worksheet number 1 only, 1 through 8. Which one would you like to do? This is your homework, and you will write on it and circle your final answer. But right now I need you to vote. So I heard 6. Anybody want a different one? Okay, so first of all, The entire worksheet, all 4 parts, front, back, are going to be homework. But right now, you're not working on this. We're not done. You're going to do one problem with me together as a whole class. We're going to vote on one problem on the front side, 1 through 8, and then you're going to put it away for a few minutes, okay? So front side worksheet number 1, I heard number 6. Anybody have a different vote? 6 or 4? Raise your hand if you want 6. Okay, hands down. Raise your hand if you want to do 4. All right, we'll do 6. So number 6, you can write on the worksheet. We'll do it together. So we're supposed to simplify completely. What can we do first? Is that not? Yeah. Worksheet number 1 only, not the quiz. Number 6. Okay. All right, so what can I do? Okay, simplify the square root of 54. What will 54 factor into? Okay, so 9 times 6. 9 would be the biggest perfect square that will go in there. Take the square root of each one. What's the square root of 9? 3. So this is going to become 36 over 3 square roots of 6. What can I do from there? Before I rationalize the denominator, always look for ways to make your number smaller. So what could I do first? Okay, 36 and 3 both reduce, so I could divide them both by 3. You're going to have a much harder time if you don't always check for a way to make it smaller every single time. So 3 goes into 3 once. How many times does it go into 36? 12. Okay, so now we have 12 over the square root of 6. What would I do next? Okay, so yes, we would rationalize and multiply by the square root of 6 over the square root of 6. What do I get on the top? 12 square roots of 6. What do I get on the bottom? 6, because remember you're going to have the square root of 36, which is just 6. You should never have a square root left in the denominator when you're rationalizing. The whole point is it's going to get rid of the square root. Okay, and so then am I done? No, always check. Can I simplify? What can I simplify? 12 and 6. So 6 goes into itself once and into 12 2 times. So what is my answer? Okay, and do I need to put it over 1? No. So the answer should just be 2 square roots of 6. Ask yourself your 3 questions. Do you have a square root in the denominator? Nope. Do we have, can our square root that's left, can that simplify? Nope. And is there anything else that can simplify? No. So those are the things you want to ask yourself. If you don't ask yourself those questions, you're going to miss something on the test, I'm telling you. So be really careful. Okay, put the worksheet away, go back to your notes. Well, I appreciate that, but yeah, that's kind of the whole summit philosophy, but I'm not, I know, I have a hard time with that. Okay, let's get back to this. So now we're going to add and subtract. Add and subtract, okay? So that was just simplify, So now we're going to add and subtract. So here's some notes on adding and subtracting. In order to add or subtract square roots, I always say this is just like fractions. What do you have to have before you can add or subtract fractions? Common denominator. So same idea here, except instead of a common denominator, you have to have a common radical and a common radicand, which is the number under the radical. Okay, so you have to have a common radical, meaning they both have to be square roots, they both have to be cubed roots, they both have to be fourth roots. You can't have a square root and a cubed root. And then you have to have the same number under the radical before you can add them. So a square roots of b plus c square roots of b can be added because they both have a square root and they're both the square root of b. Does that make sense? Okay, and so then to add, you only add just like you would with fractions. With fractions, when you get a common denominator, do you add the denominators? No, you just add the numerators, right? So with radicals, you're just going to add the numbers in front. A plus C, and then that will be times the square root of B. So you get a common radical and common radicand. If those are the same, then you can add the numbers in front. Radicand is the number under the radical. So if I have this, the radicand is your C, the radical is this. The square root or cubed root or fourth root, that symbol is your radical. Okay? So that's the rule, and the same for subtracting. Say it again. No, no. The number in front is just another number in your problem. So the radical is the actual square root symbol or cubed root symbol, and radicand's a number under it. And it's the same for subtracting. That's the rule. So you're going to have to make sure, though, that you've simplified everything first. Don't just say because they don't have a common radical, I can't add or subtract them. If they can simplify to a common radical, then simplify and see how it works out. So for example, 5 square roots of 32 minus 3 square roots of 8. Do I have a common radical and radicand? No. Okay, what do you mean by divide? But this isn't a division problem. You can't just decide to divide a piece. Okay? But that you can't do that because that would be changing the entire problem. It would be like me saying you have $100, but I'm going to divide it by 5 first. That changes your entire value. Okay? Okay, so I need to simplify the square roots, right? That's the first thing we're going to try to do. So what can I simplify here? 8 and 4, okay. So 32, okay, that will work, but it's not my biggest perfect square. What's my biggest perfect square that goes into 32? 16 and 2. So again, you can do 8 and 4, but if you do 8 and 4, you're going to have to keep going because they can both simplify further. If you look for the biggest perfect square, 16 is the biggest number that will go in there. What's the square root of 16? And then I have the square root of, okay, here's the biggest mistake that is always on the test. Right here, here's the biggest number one mistake. What do you think students forget about? The 5. You should never start simplifying your radical until you bring down the number in front, or you are going to forget about it. I promise you it happens all the time, and here's the bad thing. You will get very little partial credit on this quest. Very little. It's going to be pretty much right or wrong, and each question is going to be worth 3 points. So if you miss it because you forgot about the 5, you're going to be really frustrated. Okay? Say it again. You do? What does this mean when you have a number beside a square root? It means multiply, right? So this is 5 times the square root of 32. So now it's 5 times 4 square roots of 2. What is 5 times 4 square roots of 2? 20 square roots of 2. You only multiply the numbers out front together, not underneath. Okay? Let's keep going. We're going to bring down our minus sign. And what should we bring down before we ever start here? The 3. I would bring it down before you start simplifying that 8, or you're going to forget about it. What is the square root of 8 going to factor into? 4 and 2, and the square root of 4 is 2. So we have 2 square roots of 2. And then once again, because that 3 was out front, that means 3 times 2 square roots of 2, which becomes 6 square roots of 2. So when we first looked at it, we would have said, no, we can't subtract them because they don't have a common radical. Now we look at them and we say, yes, we can subtract them because they have a common radical too. Right? So what is our answer when we subtract? Good. Just the numbers in front, so 14, and then leave your common radical square root 2. And then again, you're asking yourself, do you have a radical in the denominator? Nope. Can your radical that's left simplify? Nope. And is anything else able to simplify? Nope. Any questions on adding or subtracting? Okay, take your worksheets, turn it to worksheet number 2, which is on the back of the first page. Yes. So look, 1 through 9, you guys vote. We'll do one together. This is on worksheet number 2.
Number 6, but if you look at the number
6. Okay, I heard 6 and 9. Hands up if you want 6. All right, that's the majority. 6. All right. So we have 4 square roots of 75 plus 6 square roots of 27. We do not have a common radical right now, so we need to work on simplifying first. Bring down the 4 before you start, or you're going to forget about it. What does 75 factor into? Good. 25 times 3. Square root of 25 is? So we have 5 square roots of 3. Go ahead and simplify that. What's 4 times 5 square roots of 3? 20 square roots of 3. Bring down your plus sign. Then bring down the 6 before you work with that 27. Okay, what does 27 factor into? Good. 9 times 3. The square root of 9? 3. So I have 3 square roots of 3. And then go ahead and multiply. What's 6 times 3 square roots of 3? 18 square roots of 3. And now do we have a common radical? Okay, and it could be that you may not get a common radical. So just because it says add or subtract, you may simplify it down and you may not get a common radical, but you still simplify. So if this had been 18 square roots of 4, we would have still simplified it, but we would have just circled what we got there at the end because you can't add them any further. You wouldn't go back and circle the original problem because that's not simplified completely. Okay, so simplify completely means go as far as you can. But if you can't add because they're not the same, then you just don't. That's your answer. We can here, so what's our final answer? 38 square roots of 3. Okay, and again, you're asking, do you have a square root in the denominator? No. Can your square root simplify? No. And can anything else simplify? No. And I'm going to keep repeating that so that you're thinking about those questions. All right, last thing is multiplying and dividing. So again, put your worksheet away for a minute, please. Go back to your notes. All right, so now we want to multiply and divide. So I'm going to give you some rules about multiplication. For multiplying and dividing, first of all, if you have the square root, oops, I don't like that. If you have A square roots of B times C square roots of D, to multiply, you are simply going to multiply the numbers out front together, A times C, and then you're going to multiply the numbers underneath the square roots together. And really, if you think about radicals, there's a lot of similarities to what your rules are for fractions. So just think about your radical being like the denominator part of your fraction. Okay? So you would just multiply the numbers out front, multiply the numbers underneath. But then you're going to check, can your radicals simplify? Okay? So make sure, and if I were you, I would try to simplify these before I ever start so that the numbers I'm multiplying are not large numbers. Okay, so always check to reduce before you multiply. Okay, if you have, so that's the first thing. If you have something like square root of A divided by the square root of B, you can just write that as a fraction. So this would become square root A over the square root of B. And then you would go back to what we talked about the very first part of the notes. Try to simplify. Check and see if you can reduce them first. If they can reduce, reduce. If not, then simplify each one separately and go from there. Okay, so if it just says divide, you're just writing it as a fraction and simplifying. If they give you something like the square root of A over B divided by the square root of C over D, over the square root of D, sorry. So first thing I would do is check to see can anything simplify or reduce. And you're going to do that for every one of them. Can A over B reduce? If not, break it apart into square root of A over square root of B. Check and see, can C and D reduce? Is there anything that can go into both? If not, leave them as square root of C over square root of D. they're both under the same radical, you can reduce. And if they're separated, you can still think about them as being able to reduce. Yes. Okay. So then we would rewrite this as square root of c over square root of d, just separating all of them if we can't simplify anything. Okay? At this point, how do you divide with fractions? Very good. Multiply by the reciprocal, keep, change, flip. Took me a minute the other night. Brendan was asking me a question about proficiency, and we weren't in the same room, so he's texting me, and he said, oh, never mind, KCF. Yeah. And I was like, KCF, what's he talking about? And I was like, keep, change, flip. But it didn't register for a little bit. I was like, KC, what's he talking about? All right. So, yeah, that's kind of what I thought. I was like, is he hungry? Are we talking about, we got his letters mixed around, KFC? Yes. All right, so keep, change, flip is what you're going to do. So you're just going to rewrite this as square root of a over square root of b, keeping it, change it to multiplication, and flip the second one. So this becomes square root of d over the square root of c. And then again, now that you flipped it, I would look to see, can anything reduce? Maybe a and c can reduce, a numerator with a denominator. Maybe b and d can reduce, a numerator and a denominator. So look and see, can any numerator reduce with any denominator, and then multiply straight across. Okay, and I'll give you an example where we'll look at it. So if I can't simplify anything, then I would write this as square root of a times d over the square root of b times c. Because remember, you multiply the numbers under the square roots together. And then again, you're going to look to see, can anything simplify? And if it can't, then you're going to rationalize, because you can't have a square root in the denominator. And I'm not going to do that with variables, okay? We'll do it with numbers. Is everybody with me there? Okay, so let's try a problem. I'll give you an example that's like this, because that's probably the hardest out of all of these, right? So let's do one that's similar to this, and then I'll let you pick one off the worksheet. So first example, we have square root of 3 over the square root of 18 divided by the square root of 8 over the square root of 72. All right, so what do we want to do here? Simplify what, Edwin? 8 and 72. What goes into both 8 and 72? Okay, you could start with 2, but 8 goes into both, right? 8 times what is 72? 9, right? So you could do 2 and then realize, oh, wait, more will go into it if you need to. Okay, so this becomes divided by the square root of 1 over the square root of 9. Do you want to go ahead and simplify that a little bit first? So I'm just rewriting that. So how would this simplify? Right here? 1 over 3, right? The square root of 1 is just 1, and the square root of 9 is just 3. Agreed? Okay. Okay, so what else could we do? Okay, simplify 3 and 18. What goes into 3 and 18? 3. So 3 goes into 3 once and into 18, 6. So that becomes the square root of 1 over the square root of 6 divided by 1/3. Can I simplify that? What is the square root of 1? 1. So go ahead and simplify that. Square root of 1 is just 1. So now we have 1 over the square root of 6 divided by 1/3. Can we simplify anything else? What could we simplify? Okay, I would tell you to wait before you try to rationalize until you've actually done the operation. So this is a division problem, so we are going to need to divide eventually. But can we simplify anything else? No. Now I want to warn you back up here. 8 and 18, those could simplify normally if this was what kind of problem? 8 and 18 can simplify if this was not a division problem, but it was a what? Multiplication problem. So I would tell you to be really careful. You can cross-reduce if you're multiplying, but you cannot cross-reduce if you're dividing. Okay? So you can cross-reduce if you're multiplying. You cannot cross-reduce if you're dividing. So just be really careful to look for that if it is a multiplication problem. This needs to become a multiplication problem. What do we need to do? Keep, change, flip. So 1 over the square root of 6 times 3 over 1. Go ahead and multiply straight across, and what do we get? 3 over the square root of 6. And now we're ready to do what Sarah said. We need to get rid of that square root in the denominator. So we're going to multiply both the top and the bottom by the square root of 6 over the square root of 6. And I never said this today because you guys were like, oh, I remember we did this. But do you understand why you can multiply the top and bottom by the square root of 6? What is this the same as? 1. So you can't just decide to multiply or divide because it changes the value of your number. But you can multiply or divide by 1 because it doesn't change the value of your number. Okay, so that's why we can get away with this, is because we're doing it to both the top and the bottom, which is keeping our value the same value. All right, multiply straight across. What do we get? Are we done? No, good. What can I do? Okay, simplify. 3 goes into itself once. 3 goes into 6 twice. So what's our answer? And then you ask yourself those 3 questions again. Do you have a square root in the denominator? No. Can you simplify the square root? No. It does factor into 2 and 3, but there's no pairs, right? And then the last question, can anything else simplify? No. Cannot simplify a 6 and a 2 if one's under the square root and one is not. Okay? Is that the one that we did together or the one I picked? One picked. Okay, so now you can pick. Go to worksheet number 3. And Bree, we miss you today, so if you're watching this video, we're trying to take good notes for you here. Worksheet 3. 8. Anybody else have a different option other than 8? All right, everybody agrees unanimously. We're doing 8. Okay, square root of 56 minus the square root of 2, parentheses, negative square roots of 9 plus 9. Okay, first thing I want to warn you about right here is something you learned way back, pre-algebra, PEMDAS. Very good, Kaden. PEMDAS. Make sure that you follow your rules for PEMDAS. Please excuse my dear Aunt Sally. P stands for, so work inside your parentheses first. So let's do that. I'm going to copy this down. Square root 56 minus square root 2, parentheses. What can I simplify here? Okay, so the square root of 9 simplifies to 3. So this is negative 3 plus 9. Can we go ahead and simplify that at the same time? Okay, so negative 3 plus 9 is just 6. Is that okay that I didn't show the negative 3 plus 9? Everybody with me? Okay. So where do we go after parentheses? Exponents. We look for exponents. E stands for exponents. Do we have any exponents here that we can work with? No? Then where do we go? Okay, and it's actually multiplication and division together from left to right, right? So we multiply and divide from left to right. So do I have anything here that I need to multiply or divide? Nope. Keep going. What am I doing here? Okay, subtracting, and then next, multiplying. So I can rewrite this as square root 56 minus, minus 6 square roots of 2. So all we did was just multiply 6 times the square root of 2 there. Okay, so after we multiply and divide from left to right, then we add and subtract from left to right. Okay, talking PEMDAS here, so making sure we're thinking our order of operations. So we cannot subtract. There's nothing being added. We can't subtract right now because we don't have a common radical. So then we simplify. So what does 56 factor into? Okay, and again, we're trying to look for the biggest perfect square. 8's not a perfect square. 8 and 7 is a factor, but it's not a perfect square. Can you think of a perfect square that goes into it? 4 and 4 and 14, right? Now, you don't have to work them that way if you can't think of the biggest perfect square. By all means, you can do 2 and 28 or 8 and 7. But if you can think of the biggest perfect square, then you can just take the square root of each one and know you're done. But it has to be the biggest. If it's not the biggest, then your number can still simplify. Okay? Square root of 4 is 2, so we have 2 square roots of 14. And 14 is just 7 times 2, so again, that doesn't simplify any further. Bring down our minus, and then 6 square roots of 2 will not simplify, right? So do we have a common radical? No. So can we actually subtract these? No, not without a calculator rounding and getting a decimal. So this would be our answer. We ask ourselves, do we have a radical in the denominator? No. Can any of those radicals simplify? No. And can anything else simplify? No. Okay? And that's it. So you